Okay, maybe let's start from the last slide. All right, and then I'm going to give Pradeep control. Get this. There we go. You should be in control, Pradeep.
All right, thanks. Thanks everyone for joining, and good morning. I think most of you are in the US, but there are also Amit and Enrico and I. So good afternoon for us and other people in Europe. So Muninder introduced me. I think that was pretty good. So thanks. Let me also introduce Enrico, who is a senior PhD student working with me. He's currently also in a research visitation in Spain. So it's quite a bit of geographical spread in the audience, at least from that perspective. So I would get going. So I think today we are talking about values, and specifically context-specific values. And then from a more technology perspective, what we are doing about values from a natural language processing perspective. So I will set the stage for this talk mostly, but most of the heavy weighting will be done by Enrico. So let's begin. So is it still working? Okay, it does. There's a bit of a lag. So here's an overview of what we will talk today. So like I said, I'll introduce the notion of values and value-related research questions that we are answering. And then, so in terms of like how we answer those questions, we start with some machine learning techniques that we are using, first more in a black box setting, and then more in more interpretable ways to answer those questions. And then we'll end with a method that we developed and how we evaluated that method. So that's sort of like the overview. The overall talk, we're expecting it to take between 30 and 40 minutes. So that should leave 15-20 minutes for more discussion at the end. Feel free to stop anytime in the middle if there are clarification questions. But if it's more of a discussion questions, it will be great if you can take them towards the end. But again, we can do it more free flow. Okay, so I think for this audience, we don't need to talk more about values, but sometimes actually people may get confused when I say values. Actually, they are probably thinking of values more from or mainly from an economic perspective. But here, when we talk about values, we're talking more like moral values or ethical values, in the sense that values are what we consider as important in life. So a lot of the decisions people make are based on values, but not all of them. So preferences can be over values, or they can also be over other likings. For example, one may like I don't know, the color red over color blue, not in a political sense, but just purely as colors. That's more of a choice or an attitude based on liking. But when we say some decisions are based on values or motivated by values, the choice is based on what people consider as important in life. So we're talking about values in that sense. So yeah, before I go further, I mean, the way I started it, it sounds like actually we're talking about values more from a philosophical sense. Of course, it's a topic that is of interest to philosophers, but I'm not one. So I'm a computer scientist. So I want to sort of like to start with set the stage on actually why is the notion of values or like value related construct is important to computer science also, in particular artificial intelligence. So a lot of traditional AI is quite technical, or also thinking AI more like one machine or one algorithm or one technique from that perspective. So then I think it's more about like, I don't know, data structures and algorithms and things of that nature, the considerations. But in my research, and also I think broadly with the research of Muninder and several other people that I know here, when we think of AI, we think of AI as a part of a larger socio-technical system, as shown here. So, so there are humans and other actors can be organizations and stuff like that. So they are operating more in the social tier. And then we have agents or broadly computational entities representing these humans in a more technical tier. So when we want to design, when we want to develop whatever solutions and techniques that we want to do for AI, we're thinking of AI as being part of this larger ecosystem. And that's when constructs like values and norms are important, because these are the types of constructs that humans or the principles in the social tier use in their day-to-day communication, decision-making, and things like that. And then if you want computational entities to represent humans in a technical tier, then the computational entities also need to have an understanding of constructs like values to make this ecosystem work. And that's the reason, as a computer scientist, we are studying values. So what we're in a sense interested in is taking these concepts from social science and trying to develop computational abstractions for that, and trying to develop actually techniques where we can learn some of these things from a data, and in this case actually data that is in the form of text, so that computational entities can use these notions. I mean, that's sort of like the broader idea as to where we are coming from or what we're interested in doing. So a little more introduction on values. Let's go to the next slide. Yeah, so to talk about, I mean, what are values and why, like, these are sort of like a universal constructs. This is an argument from Schwartz, one of the scientists who has developed like value theories and has worked on this concept quite a bit. So the notion of values is based on the notion of the universal requirements of human existence. I mean, I think some of you may be familiar with this Maslow's pyramid here. So this says that basically all human beings have a certain set of common requirements. So these requirements range from more sort of like physiological requirements, more things like we all need to eat in order to survive, that type of requirement, and also like safety requirements. So in order to be sort of like protected from other actors, I mean, in the olden days, it may be like wild animals or whatever, you need to sort of like function as a society. So there are requirements at that level. But there are also more social requirements like love and belongingness. And then there are also more sort of like self-actualization or esteem type of requirements. I mean, these are some requirements that all human beings have. And then, like I already mentioned, in order to satisfy some of these requirements, you need cooperation from other members of your species. Then what you need is you need a language to communicate these requirements or needs. And values is the vocabulary that is used, one of the at least vocabularies that is used for communicating such requirements. I mean, this is an argument as to why values are universal. And why they are also sort of like an integral part of our day-to-day behavior and decision making. So with that said, I would not dwell onto that more, but we can come back to it later if you want. Yeah, so there are some well-known theories from philosophy and social science on values. At least like one stream of thought in the values community is that researchers like Schwartz in terms of this theory, or it could also be in the moral foundation theory. That's another theory on values. So there's an understanding that although values are abstract concepts, there are like a fixed number of values that can be used to describe the behavior across cultures and contexts. For example, Schwartz identifies 10 values as sort of like these basic values, which are listed here. You can think of them along two sort of like dimensions. On the one dimension, you have values that are more self-centered, things like hedonism and achievement. And there are values that are other-centered, so more like benevolence and universalism. And that's along one dimension. Along the other dimension, you also have values that are about like requiring change, things like stimulation and self-direction. And there are also values about sort of like conserving the past, things like tradition and security there along those dimensions. But I mean, Schwartz says that actually these 10 values are, so to say, universal. With a similar sort of like idea, but like a different categorization. So the moral foundation theory identifies 5 moral domains. So I think, and in each domain there are 2 sort of like one is a vice and other is a virtue. But still, the idea is that there are a fixed number of these things that can be used to explain broadly moral behavior. That's this school of thought that we're going to mostly talk about today. Then going forward, what is that? Yeah. So continuing what I was saying earlier, this is also, I think, from Schwartz. Schwartz identifies some features of all values. So I mean, one of those is like values refers to goals. I think also mentioned this already. I mean, we're not thinking of values purely from like as an abstract point of debate. But typically when you say you have a certain value preference and that is in line with the goal, and that is important for AI because there's a lot of existing literature is already goal oriented. I mean, you develop these agents for achieving a certain goal. And then what we're doing is we're trying to go one step beyond and trying to say, I mean, why does this agent have this goal? That's because of an underlying value preference. Similarly, values are linked to affect. So I'll mention this, but we don't need to get into that now. There's standards criteria, but also what is important is they can be ordered by importance, and it's not the same for all human beings. So they are like, even going with the Schwartz terminology, there are 10 values that are sort of like applicable in many contexts, but that doesn't mean that the preferences among these 10 values is same for all individuals. So one individual's value preferences differ from another, and that's what makes it sort of like an interesting problem from a computational perspective, because how can we identify these things? Because you can use things like surveys and so on to elicit these things, but that's inherently challenging to sort of like have these surveys with a large set of sort of like people. And also a lot of the times these surveys are sort of like set in hypothetical scenarios, and typically what people say and people do, there may be a disconnect there. So learning these differences from one individual to another, I mean, that's where I think some of the more recent AI techniques can be useful there. Finally, for this talk, there is one assumption, or the one sort of like an understanding of values in the traditional literature that we critically look at and question. So which is about the transcending notion of values across contexts. Schwartz argues that these 10 values that we looked at earlier, so they are applicable in all 10 contexts. I mean, 10 values are applicable across all contexts. But then what does that mean? And then why is it sort of like not always useful to make that assumption? I think that's something that we're going to dwell into in the rest of this talk. So that's what we have here. So one challenge of sort of like taking these abstract values, like the ones that we've shown here, are that they may be applicable in many contexts, but treating them at that level of abstraction doesn't make them useful in whatever prediction tasks that we want to use them for. So then can we sort of like identify like interpretations of these values that are specific to a context, and for that reason that is more valuable for practical applications? I mean, that is what we're going to look into in the rest of the talk. Yeah, so
yep.
That's when I think Enrico, you can I can give the control back to you.
That's my cue.
There you go. Oh yeah, so you should have it back, and then you could take it from here.
All right. Thanks, Pradeep, for the introduction. And well, as Pradeep said, a concrete application for values is value classification. So as he was explaining, let me jump already to this slide directly. Why do we want to estimate values in natural language? Why is that interesting? Why is that important? As Pradeep said, using value surveys, so in essence, asking people what they value, is something that tends to be very expensive because, well, it takes time and needs to be done for large numbers of people, and it is very difficult to answer for people because there are typically hypothetical questions about what would you do in this situation? What would you think in that other situation? So these types of surveys are not really scalable, mostly. On the other hand, estimating human values from natural language, from the way in which we speak, allows, number one, to express ourselves naturally, so to express our goals. So essentially expressing what we need from, for example, from Maslow's pyramid, expressing what we care about. That the way in which we naturally do this is through language. And if an algorithm, if a natural language processing model is able to understand values from language, that means that artificial agents could be able to have meaningful conversations with us, to really understand us and understand our needs, our values, and be able to act upon them. So hope I have convinced you that it's really important to estimate values from natural language. And but as Pradeep said, we are a little bit challenging the hypothesis that values are really context agnostic, because the way in which we express values really depends on the situation. And we're going to get to that a little bit later on. So the first way in which we wanted to evaluate the context specificity of values, the context specificity of value expressions, is through so-called cross-domain classification. So essentially, the question is, if a natural language processing algorithm learns how values are expressed in language in a specific context, let's say vaccination. So a natural language processing algorithm learns how values are expressed in a vaccination discussion. Can that algorithm be used to understand and estimate values in text in another context, in another situation? So take, for example, climate change. Can we recycle that knowledge? To which extent can we recycle that knowledge? This is the first step into trying to understand to which extent values are context-specific in language expression. So what we did essentially is, well, this, essentially what I just said. Take an algorithm, train it on a specific context, on a specific domain, and see how it performs in another domain. So for the technical people in the audience, we inspected generalizability and transferability of moral expressions in natural language. So first, let me introduce a little bit the dataset that we used, because it's important for the rest of the presentation. We used a dataset that is called Moral Foundation Twitter Corpus, that is composed of 35,000 tweets divided in 7 datasets. So give or take 5,000 tweets in each dataset. And each dataset, as you can see on the right, MFDC datasets, was collected with different hashtags, essentially corresponding to different topics of discussions, different contexts, ranging from political to, for example, Hurricane Sandy relief tweets, so less political. All the tweets in this corpus were annotated with the same value theory. That is the moral foundation theory that Pradeep introduced earlier, that I'm showing again here on the bottom right. So all of these tweets were annotated with these values. So to get you to understand what I'm talking about, I'm showing a couple of examples here. So these are examples of tweets belonging to this corpus, belonging to different datasets, as you can see on the left. And several annotators indicated what value or what values they considered that is underlying the reasoning and the expressions in that tweet. So essentially using values as labels for pieces of text. So what we want is that we want a supervised machine learning algorithm to learn this into a specific context, say all lives matter, and see if this knowledge can be transferred to another context, say Hurricane Sandy relief tweets. So first thing that we checked is generalizability. Can we just do that directly? Can we just train in a specific context, in a specific domain of discussion, and use that algorithm directly in another domain of discussion? So that is called generalizability. And obviously, we've made like a lot of experiments. I'm not going to go in detail here because it's not really relevant, but the TLDR is we can kind of do it fine, let's say. NLP models can decently generalize to novel domains. We have like decent results. And performances, of course, are not really great if we have very specific and very peculiar domains, but generally they perform kind of okay. So what we checked is, okay, can we improve that? One way to improve that is what is called fine-tuning or transfer learning. So what we do is that we first train our algorithm in a specific context, in a specific data set here, and then we take a little bit of data from our novel data set where we want to test, and we retrain our algorithm with this bit of data from the new data set where we want to test from the novel context. And we see to which extent that improves performances. And that is what you can see on the right. So on the right, you can see the blue horizontal line is just testing models without retraining them in the target, in the novel domain. And the red dots that you see are retraining these models with increasing percentages, increasing portions of data from the target and novel domain. So as you can see, there is an improvement. The improvement is not very large, but it's substantial. So we're talking about 7% improvement in F1 score with just 10% of data from the novel dataset, with just a couple hundred data points, which is not a lot in machine learning. Overall, let's say we plateau to a 10% of improvement in classification in F1 score. So what does this mean? This means that models can somewhat generalize to novel domains, but if you retrain them even just a little bit in a novel domain, performances immediately improve. So this suggests that there are differences in expressions of values across different contexts. What we did here was to evaluate these with, well, training and retraining models. So as Pradeep said, with black box approaches. But then we decided to go one step further and to try to understand what are the differences and try to understand what are the differences that these models find across different contexts. How does value rhetoric change across contexts? So for doing that, we use a technique called AI explainability. I am quite sure that most of you are familiar with this because it's also, quite trendy right now. But to explain it a little bit, to introduce it a little bit, explainable AI aims at providing explanations for decisions made by AI systems. So try to understand what's the reasoning of an AI system. And to explain it a little bit further, let me make a divide between local and global explanations. A local explanation explains the reasoning behind a specific prediction. So if we're trying to classify cats and dogs in photos, we would ask the model the question, why did you classify a cat in that photo? That is local explainability. On the other hand, global explainability tries to explain the overall decision-making of the system. So we would ask the model, why do you classify cats in photos in general, not in specific instances? Both are very important, of course, local and global explainability. So what do we do with this? What do we do with this explainability? Why is this important? Well, we use it to inspect how value rhetoric changes. What are the differences in which people express values in different contexts? The reason why we do this, well, first of all, is to continue in our quest of exploring the hypothesis of context specificity of value expressions, but being able to explain the differences in moral rhetoric is really important also for social scientists, policymakers, because it makes social scientists and policymakers understand how people reason, how people express and reason about the same concepts, but in different situations. And that is very important for, well, understanding people on a way, and on the other hand, understanding people's preferences and value preferences across different contexts. So we have essentially continued our experiments from before. So we have used the same models as the experiments that I have mentioned before, used the same data set, and we have essentially investigated the explainability angle of the experiments that we did. So we did it in this way. So we took a natural language processing model, BERT, and we took an instance of that, and we trained it on one of these data sets. So what you can see over here on the top, right? We trained the model on dataset 1, let's say, or Black Lives Matter. And in parallel, we trained another instance of the model on another dataset, say Hurricane Sandy relief tweets. Then we applied SHAP on both of them. SHAP is a popular explainability method that essentially identifies the impact that features have on a certain label prediction. What this means in our example is how important was a certain word for the prediction that the model made on that tweet. We have aggregated that over all the datasets. So essentially, we have created value lexicons, lists of words ordered by the importance and the impact that they have over the decision-making of the system. So how important are words for the model for predicting a certain value? We've done this for two datasets. We've done this to compare two datasets, essentially. And then we got numbers of comparison, both quantitative and qualitative comparisons. So I'm not going to go in detail in the quantitative comparisons because it can get quite long, but I'm going to show you a few examples of what I think are very interesting qualitative comparisons and differences across these datasets. Let me take two datasets that I assume all of you are familiar with, which is All Lives Matter and Black Lives Matter. In a way, these datasets are quite similar, because if you think about it, All Lives Matter and Black Lives Matter are contexts in which people tend to talk about the same situations, the same situations and the same people, right? Especially if you compare them with, for example, tweets about Hurricane Sandy, right? Obviously, All Lives Matter and Black Lives Matter tend to be much more similar in their topics of discussion than Hurricane Sandy relief tweets, right? Indeed, we did find that they are quite similar, and we found, for example, that when people talk about fairness, in both of these contexts, they use words such as equality and justice. And when people talk about cheating, so yeah, the opposite of fairness, right? Betraying somebody's trust. They use words such as fraud, fraudulent, corruption. So we did find quite some similarities, but we also found differences. In particular, we found differences when people talk about the value of subversion. So subversion is, well, it's talking about essentially rebellion, subversion towards higher powers. And what we found is that in All Lives Matter, in ALM, subversion is expressed with words such as, with negative words that put subversion in negative light, such as overthrow, mayhem, which makes us sort of assume and conclude that subversion is frowned upon in this specific context, in a negative light. On the other hand, in Black Lives Matter, we found that people express subversion with words such as encourage and defiance, which put the concept of subversion in a positive light. And this is, let's say, anecdotally known in a way that this difference exists between ALM and BLM, but it's very interesting, it's very insightful to find this in actual empirically. And this, of course, can be used in many more types of applications beyond also, for example, even just if you think about it, finding how differently people talk about climate change in the US versus in the Netherlands. Yeah. So going back to the hypothesis that Pradeep introduced, do values transcend contexts? The answer is no, with an asterisk. So what I mean is that the way in which we express values in language does not transcend context. The way in which we express values in language is context dependent. And I'll get to the asterisk in a little moment. But since we express values differently in every different context in life, so say in climate change versus vaccination, at this point, let me challenge you with an idea. Why not talking at this point about why not introducing different value systems, different value taxonomies, different value theories in different contexts. If the way in which we talk about them differs, why not using different values at that point? So let me explain a little bit better what I mean in the last part. I'm almost there. So far we've been talking about basic human values. That's what Pradeep introduced in the introduction. Basic human values are general, abstract. They are intended to be applicable across contexts because they are intended to explain who we are, to explain us as humans. But these basic human values are very difficult to use in concrete applications. For example, if I want to know the way in which people talk about vaccination, it's very difficult to use concepts such as universalism and self-transcendence, right? It's just very vague and difficult to situate in a specific context. That's why, on the other hand, we introduced the concept of context-specific values. Values that are intended to be applicable and defined within a specific context, so in vaccination or in climate change. And they're intended for concrete usage. So, for example, to explain the way in which the value preferences of people in vaccination, in climate change, and not to understand people as a whole as humans. Let me make an example, for example. Let me talk about two specific data sets that we used. So one data set that we had was about COVID-19, of course, and the other data set was about the green energy transition. In COVID-19, we found that people, for example, really care about being able to have fun, the value of enjoyment. And that's something that is very important for people when debating about COVID-19. And that's something that is not debate, it's not part of the conversation when people talk about green energy transition. On the flip side, in the dataset that we found, but also, in the Netherlands, but also in the US, as far as I'm aware, a very important value, a very important point of discussion for people is landscape preservation. So making sure that the landscape is not polluted by windmills, for example. And this is something that is important for people. They consider this as a value. And this is something that is not really relevant to the discussion of COVID-19, right? So there are different values that are relevant in different contexts. And that is why we have proposed a methodology that we call Axies. There is a hybrid methodology for identifying what values are relevant to a context and to define them in this context. This methodology is hybrid, meaning that it's a combination of human and artificial intelligence, and it's supported by natural language processing. Essentially, what we aim to do is that we want to make sure, so we want to identify which values are relevant to a context, and we want to avoid that just one person, one philosopher, or one policymaker just sits in a room and thinks about what values are relevant. But we want to make sure that this process of value identification is guided and supported by input provided by a population. So it's inductively, this value list is inductively generated from input provided by people. So how does Axies work? Looks complicated, it's not. On the left, we have the input for Axies. We have a discussion, a societal discussion. So an opinion corpus composed of value-laden opinions. Think about answers to a survey about vaccination, or tweets with a certain hashtag about face masks. And on the other hand, on the right, we have a value list. So we want to identify a list of values that are relevant to this discussion. In the middle, we have Axies, a methodology to be performed by value annotators, a small set of people, and is divided in two parts, exploration and consolidation. I'll get to that in a moment, both supported by natural language processing. Let me see here. Okay, I'll try to go fast. So The first step is exploration. We want that each individual annotator finds their own value list. So we want to ensure diversity, right? That everybody can explore these data on their own. And what we do is that we basically take all the opinions in the corpus, all the data that we have, we embed it to an embedding space. You just don't need to know the details. Just imagine that all the similar answers to the survey are in the similar part of an n-dimensional space. And what we do is that we guide our value annotators through the furthest parts of this embedding space in order to show them diverse and different opinions that are representative of the data set. And we ask them to identify the values that people who wrote the answers of the survey, for example, held when writing these answers to the survey. So to identify the list of values that are relevant to this data set. Then we put together, then each individual annotator finds their own value list, and we put together all the annotators in the same room, and we tell them to merge their value lists. The way in which we do it is to, again, use natural language processing moderation to guide them through this process. And what we want is that we want that similar values are merged together and differing values are listed out. Essentially, what we get at the end is a list of values that are relevant to this opinion corpus, to this discussion. So to keep it quick, we have evaluated these on 2 data sets to compare the context-specific values that came out of it, and one about COVID-19, as I said, and one about green energy transition. And what we investigated is the context specificity of these values compared to the basic human values, like Schwartz values, and the differences between these context-specific and basic human values. I'll go a little bit quicker since we already took a little bit too much time. The first answer is yes, Axies yields values that are more context-specific than basic Schwartz values. So values that are considered to be more relevant to the topic of discussion rather than general Schwartz values, according to the experts that answer to our experiments. Then we have investigated the difference in the usage of these values. How differently do people use these values in a concrete application? So we asked lay people to annotate pieces of text with these values. So we asked them, hey, which of these values is relevant to this piece of text? And we asked them to do that with Axies values, context-specific values, and with basic Schwartz values. And we saw that on the left, we saw that people used twice as much Axies values to annotate rather than Schwartz values. And they did that with a clearly higher agreement, showing that it's easier and more intuitive for humans to annotate text, to use this concretely with context-specific values rather than with basic values. Finally, we investigated the relationship. So like how are these 2 different sets of values related? And what we found is quite interesting. So we found, so at the x-axis, you see basic values, Schwartz values. On the y-axis, you see context-specific values generated for green energy transition. And we saw that not all Schwartz basic values have a clear correspondence, have a clear relevancy. So as you can see, for example, the value of conformity is not considered to be relevant for the discussion of green energy transition, but the Axies values that are relevant are related to many context-specific values, so with a one-to-many relationship. So what does this mean? This means that not all basic values are relevant to all discussions, which is something that the philosophers themselves acknowledge, but then those that are relevant are actually explained in a more fine-grained way, are detailed by the context-specific values that they relate to. Giving, of course, allowing for much more fine-grained insight in what people care about in this discussion. So let me close it here. What did we talk about? We talked about value expressions. Value expressions are context dependent. The way in which we talk about values depends on what we're talking about and the situation in which we're in. And we proposed a methodology for identifying which values are relevant to what context. Then what do we do next? What do we do with everything that we have talked about? Well, what do we do is that we can use this methodology to identify which values are relevant to a certain discussion. Let's say that we have a survey about vaccination. We can identify what values are relevant to the discussion of vaccination. And then we can start to label our vaccination data with these context-specific values. Although the problem is that if we do this, well, for every new context, we have new values, so we need to collect new data. So we're going to have a problem of data scarcity. And value annotation is subjective. So we will need to make sure that we take into account diversity into this. So these are our next steps that we're going to be working on. Thank you so much. Thank you for the attention. And thanks to all of our collaborators. And also, you can see here, if you're interested, the publication that we have talked about, plus we have talked about another publication that is currently under review. So for anonymity reason, it's not here, but you can ask me. All right, maybe I can stop my screen sharing.
Yeah. Okay, thanks a lot for your presentation, Pradeep and Enrico. Let's open it up for comments and questions from everyone.
Yeah, should I just? Okay,
yeah, let's give people a minute to catch their thoughts.
I see raised hands.
No, so, yeah, Bill. Yeah, please go ahead.
Falco had his hand up first.
All right.
Is your value like orderliness or fairness?
I'm okay with you going first if you want to, Bill.
Yeah, we have time, so either of you can start.
Okay, you're muted, William.
Thanks. Okay, yeah, thanks for a great presentation. I have a number of questions. I'll just try to limit it to one. I have questions about some of the input and some of the methods and assumptions. But one specific question, maybe I can come back to other ones later, depending on time, is you use this phrase, which is central to the presentation and what you're doing, that value expressions are context dependent. What exactly do you mean by value expressions? Do you mean that the truth value of what is expressed changes from context to context, or how people interpret it or react to the expression changes in context?
Yeah, yeah.
Go ahead.
Yeah, so I would say that it's mostly the way in which people talk about values. So to make an example, let's take the example of safety, the value of safety, the value of security. If we talk about COVID-19, we're going to be using words such as mouth masks. We're going to be using words such as social distancing. So the way in which we talk about it, and consequently the way in which we interpret it, is different than, for example, to make another example, autonomous driving, where safety means to wear safety belts, to keep distance. So the way in which we talk about it is different, and then consequently the interpretation of it is as well. Does that answer your question?
A little bit, yeah. So I guess I'm still not clear if it changes the truth value, whether, something expressed in one context that, say, X is some action, X is acceptable, is true in one context and then false in another.
What do you mean with true and false?
Well, it's true that something is correct or incorrect or valuable or not valuable.
Yeah. I think the acceptability, I think Bill's asking that, would you say that in the Black Lives Matters context, something is good and then you go to the Me Too context and it becomes bad?
No, but I think the point with values is, there's no something is good that is universal. So I mean, I would say something is better than other, and you would say something. I mean, I would say A is better than B, but you can say B is better than A. That's your value preference. But that expression, if I say A is greater than B in one context a certain way, I wouldn't say that A is greater than B the same way in another context. I think that's basically what we are after.
So values do not specifically relate. So there's a difference between morality and with values, right? So values is what we consider important. So say wearing a face mask, there's the debate between freedom versus safety, let's say, right? And that doesn't mean that one thing is right and one thing is wrong. Obviously, for you, one thing is right and one thing is wrong. But I would argue that it is personal and it is a value preference, is not a moral decision.
Okay, so we
am
are.
Am I getting to dangerous territory with stating these kind of things? I think so.
Definitely. That's okay. I mean, we're still meaning sort of moral pluralism, which
it's good.
I'm happy about it.
Yeah,
it's certainly on the range of options to consider in meta ethics, for example. Okay, thanks. I appreciate it.
Yeah, thank you.
All right, so I have two worries. One relatively solvable, the other more substantive, and a quick question. So I'll start with the worries. So first of all, your data set is Twitter, which raises all sorts of problems by itself. I'm not saying that it's not valuable work, but I'm always concerned about the intrusion of bots in Twitter and the artificial language used there. So perhaps this is just my thinking, take it or leave it if it's constructive or not. But using blogs as the data set, which are blogs are more likely to be written by humans as opposed to generated by some sort of AI somewhere. That's the first worry. The second worry is, I mean, as you noted, explainable AI is quite fashionable these days, but the model you were using is a post hoc model. And knowing as much as I do about cog-sci and research and neurosciences, I know there's a problem with all post hoc explanations. And that is that how are you sure it's not just a confabulation, right? The problem is if you're relying only on post hoc models and not trying to correlate it with other approaches, it's hardly generalizable. So that is, I mean, this is not directed only at you or this particular research, but I'm thinking that in the future, there should be more sort of acknowledgement of the limitations of this approach. And how can that be improved by using other approaches from explainable AI and other approaches that basically, when we were trying to open up the black box of natural neural networks, we came up with a lot of different solutions, and kind of to acknowledge the difficulty in resolving that. Now, last but not least, the quick question. So in the laypersons who are evaluating, you just said the laypersons, you did not provide the number, composition, and things like that. And going on my second worry, in reporting anything in cognitive science or psychology or even neurophilosophy and neuroethics, you need to be more specific about how many people were evaluating, how they were recruited, and things like that. Those are my worries and question.
Yeah, so if I can answer, I'll try to answer in order. So for the Twitter, yes, I absolutely understand. Indeed, that's why in the last example, the PD example, the example of Axies identifying the values, there we used survey data where we were for sure certain that there were no bots. And indeed, that's the kind of direction we would like to go overall. Overall, we would be interested in working with more participatory systems, and that's where we want to go. And I absolutely understand the worries. Indeed, it is a problem. The second of the post hoc explanation, yes. So philosophically, I am against black box models, but it's, you know, in a way easy to be philosophically against something, right? So till they perform sensibly better than explainable models, explainable classification models that are inherently explainable, then it's hard not to use the black box model. And then with black box models, essentially the only thing you can do is post hoc explainability, right? There's not really much more that can be done. Everything is post hoc. So there should be more research in inherently explainable models. I agree, but yeah, I mean, I cannot do much more than that. Unfortunately, yeah, it's not. I'm not working specifically on that field. Wait, what was the last question? Sorry.
About the annotators and their population and their stuff like that.
Yes. So all that information is of course present in the paper. Both the annotators of the data set and the annotators of the evaluation, I'm saying obviously, but unfortunately, obviously, were weird, right? Western, I don't remember the rest, I just remember Western, but well, white, educated, Western, and etc. So especially the annotators of the Twitter dataset were American students. All the tweets were American-centered in the topic. And the evaluators that we had were mostly European because of time zone of the tests. Yeah, that's also a problem indeed. And yeah, but difficult to address, let's say, with limited resources.
Oh, there are views to or ways to address. I'm going to the sort of explainable AI. There's saying that there's no other choice but to use post hoc models. That's not entirely true. I mean, there's proxy models for ones, and also there is this kind of increasing trend in trying to use artificial cognition in using the cognitive science and cognitive psychology methods in testing out black box models to see how they perform in terms of identifying boundary conditions and things like that. So basically using the black box model as a experimental subject, quote unquote, to kind of infer. So the underlying assumption is if both the proxy model and the post hoc model and identifying the boundary condition point to a similar direction, then you can generalize. Yes, this is how the model is behaving, and that this is what. Otherwise, this is like correlation. It's a good start, right? But we need to be careful about how much we can generalize.
Yeah, but then.
Yeah, go on.
Yeah, no, absolutely. But then none of them is really an explanation of the model. Like if we want to talk about the real definition of an explanation of the model, right? No testing the boundary. Yeah, there's a term for that I don't remember, but yeah, I know what you mean. Yeah, so all of those are just playing around. In a way, post hoc explanations, you could call them.
Yeah, so I mean, one other quick comment on that is in another project. I mean, this, I agree, right, what you're saying. So another way to think about this is to not do it one shot, but do it more iteratively. So it's more like inject knowledge and then extract knowledge in terms of explanations, and then see if the extracted one, how we can change the inject. And if you do it in a few loops, then you get a better sense of is this whatever is being picked up by the black box model that is based on some inherent underlying phenomena, or is it more arbitrary? But yeah, but I think this is like exciting, but it's quite a bit of work to be done there, I think.
Any more comments? Yeah.
I have a quick question. First of all, very interesting work. So my question is, you said you fine-tune some models. What kind of models do you fine-tune? Are these like transformer-based architectures? Or...
Say it again, sorry, I didn't hear the last part.
You said you fine-tune models. What kind of models do you fine-tune?
So we used BERT. It's a natural language processing algorithm.
Okay.
And so again, like fine-tune, maybe we haven't used correctly the term fine-tune, but essentially what I mean is that it's more, the correct term is transfer learning. So we used it first, we trained it on a model, and then we retrained it on the target model where we wanted to evaluate its performances.
Okay.
I have a question on that transferability. So have you adopted other domain adoption algorithm or transfer learning, or you just use different data set?
Yeah, no, so we haven't. That's something indeed that, let's say, we put in the future work as something interesting to be done, but that, well, was a little bit, was a bit too much for us. But yeah, that's something that can be very interesting and we should test, but we haven't tested yet.
Yeah, but Sherry, I think, yeah, for now it's the data set that is new, that's all.
Okay, thank you.
Any last comments from anybody?
I have one quick question. If there's not time to answer it, that's fine. This is really goes beyond your project, I think. But it's very linguistic based, and that's understandable because we have these large data sets, you know, where people are using language to express values. Is there any possibility, or is there anybody doing anything on observing behavior and trying to make value inferences or value classifications from just behavior, like, I don't know, using TikTok data where people are doing things, or, you know, observing animal behavior and trying to extract values from that and contextualize it? Is that
What do you mean?
possible?
What do you mean exactly with behavior?
I mean, just observing people's actions, non-linguistic behavior, what they do, how they interact, how they treat each other.
Yeah.
You could do that with animals, for example, in a zoo. That would be like, I guess, a simpler case or a model case. The way, you know, one gorilla goes over to another to give it water or something. Humans do the same kinds of things. Is it possible? I mean, you would obviously need perceptual data for the input, and maybe we don't have that, but could you see that being a research project?
Yeah, I think that's a good comment. I think we're doing something along those lines, but it's still related to, I would say, language, a bit more than just the actual text itself. So we're looking at more sort of like audio and also video data when people discuss. So like this multimodal cues, when like something that is important to you, when somebody else says actually how sort of like, so you sort of like change your sort of like eye gaze, or when you say it, the way you say it. Actually, we're also looking at data of that nature in like another project that is starting now. But like, I mean, yeah, I know what you mean. That's still related to language, but also the way you express language. So it's not just the text itself. There are other cues about the way you say it. And then I knew some of my colleagues, they were looking at people sort of like sitting in like a car simulator for automated driving, and depending on the type of decisions they were making based on other cars, like overtaking or like how fast they apply for brakes and stuff like that. So I knew they were also trying to infer values based on data like that, but I only know some high level details, but I don't know what exactly they did there.
Okay, thanks. That's interesting. Thank you.
Yeah, we can certainly talk further offline about these kinds of things.
Yeah. If you have any questions, feel free to contact us. I guess maybe Amanu can share our contacts.
Yeah, sure.
Yes, thanks a lot. This was a nice presentation, and also a very good discussion following that. So I think I'm glad we did that. This is and Enrico and Pradeep will be welcome to attend our future meetings as well if they have the time.
Is it the same time every week, or
we're trying for same time every other week or every week, depending on when we get victims. So okay. Thanks a lot, everyone. See you next time.